said, the CRC has been in operation since late 1992. It has delivered an enormous number of technologies, and there's no way in the world I'm going to do justice to any one of those technologies. Just the technologies in the third term, so from 2005 to 2012, we had a 3-day workshop. So in 35, 40 minutes, I'm not going to do justice to 21, 22 years of research. So what I thought I should do is to make you aware of groups of technologies. I'm not going to describe all of them, so I'm just going to make you aware of the groups of technologies and where you can find more information. And I figure if I can do that today, then you can go and chase more information and chase the contacts. So our website information that's in the proceedings, I've got it on one of these slides as well. You should go and access the information from the web. And you will find that there are names and contact details of both the researchers and the extension people that can help you to implement any of these technologies in your own businesses. So, that is a pretty important resource that I'd be very pleased if you could use. So I'm not going to deal too much with specific technologies. I will look at the impact of those technologies in beef businesses and in the national economy, and in particular on efficiency. But what I wanted to do was to actually put it in the context of an opportunity. I suspect you're all familiar with this opportunity. We've got the Livestock Revolution. Have you heard of the Livestock Revolution? It's actually an economic model developed by the International Food Policy Research Institute and the World Bank. It was developed in the late 1980s, and it basically predicted that as disposable income in developing countries increased, what consumers in those developing countries would be seeking was more protein. In other words, animal-based products. And so if you actually look at meat consumption, so it doesn't differentiate beef, chicken, pork, you're seeing that in developed countries, up until 2011, there was a steady increase in meat consumption, but it's predicted from then through until 2050 to either stabilise or decline in developed countries. So no major change in meat consumption patterns in the developed countries. But in many of the developing countries, India accepted, but obviously there's going to be a change even in beef consumption in India. But in particular, in China, beef consumption, meat consumption is predicted and has started to occur, is growing exponentially. And so if every person in China increased their beef consumption by 0.5 kilogram of beef per year, the world can't provide that beef demand. We just have no capability at the moment to provide that demand. So that's one market. And there are huge markets in Brazil. Brazil's self-sufficient, but South America, Africa, where meat demand is increasing substantially. So there's a huge environment, but there's also a huge challenge to achieve that opportunity. So in order to meet the demand that's anticipated through until 2050, we need to double beef production. The world has to double beef production. It could be done perhaps in China, in places like China, but the rate of growth of their population and the expansion into their rural land is so great that it's probably going to need to be done in countries like Australia. So beef production needs to double in an environmentally sustainable way, so we can't ruin the environment. We need to maintain the resource base. But we're either going to have less or more expensive land, water, grain, energy and labour. So the only way we're going to be able to do this is to produce far more from less. And that's actually the definition of efficiency or productivity. So that's what we're aiming to achieve. How will we do that? The economists have awful difficulty trying to actually estimate productivity on an individual basis, individual business basis, or even at a state or national level. They struggle with that concept. So us coming in and telling people like me coming in and telling producers that what you've got to do is improve your productivity, if the economists can't measure it, you're going to struggle as well. So from the CRC's perspective, the best way that we believe producers can focus on efficiency and productivity is actually to focus on profitability. That's something you can control, you can measure, you can understand. So very simple. I'm teaching you how to suck eggs here, but profitability is just income minus the costs. Income can be controlled through price, increase your price, just accept your price, and if the market fails, you have no price, or you can increase your throughput. But you have an opportunity to focus on all of these factors. So price and throughput to increase income, and you focus on costs or cost of production to reduce your costs. And you shouldn't ignore either side. A lot of people are focusing on cost of production but forgetting the income side. And it's actually the income side that you actually have a lot of control over. And I suspect that that's not well recognised, because producers think that they are price takers, but in fact they have a lot of ability to control both price and throughput. And so we can divide that up. Price I've already been discussed, both quality. Quality is the key, and the market's there. Then we've got throughput, which can be impacted by a whole range of technologies that are under your control, and costs. We can also reduce costs. So I'm suggesting that if you're going to improve productivity or efficiency, the way to do that would be to focus specifically on profitability. And so that's what I'm going to talk to you about now, about the groups of technologies that can impact on your profitability. This diagram is in the proceedings, so I'm not going to go into it, but do recognise that we have three distinct CRC terms. We have impact assessments from CRC 1 and 2 terms that are proven, they are realised impacts, so we've been able to go into industry and measure the impact. The impact of CRC 3 is a future or anticipated impact. So that's traditionally the economic prediction of the economists. So I've been suggesting to you that you need to focus on profitability in the same way the CRC success was measured in terms of dollar value add to the Australian beef industry. And that is a pretty important point. It guided all of our thinking. The Commonwealth said to us that we expect that you will value add companies that are your commercialisers. So in the case of vaccines or breed plan, it was the companies that were delivering those products. So we expect that they will get enough benefit out of your technologies that they will stay in business. But that's not how you will measure, you CRC will measure your success. Your success must be measured by on-the-ground benefit to the beef industry. And so that actually changed the way we thought of delivering our technologies. I know that in all three boards, CRC boards, the board sat there and deliberated whether commercialising through an IP path that might bring benefits back to the CRC was the way to go, or whether we make it available in the public domain and let everybody and anybody who wants to pick it up, whether that was a better way to go. So some of the success that we've been able to achieve through the CRC was driven by this policy of needing to prove value to industry. So I've said that I'm not going to go through all the technologies. I would encourage you to look at the website, and if you want further information, to contact the people that are named there. What I'm going to do is now just very briefly run through technologies in 3 areas. So the first is a group of technologies that we called or we designed to improve compliance with beef market specs. The second was to improve animal welfare and, as a consequence, to improve productivity. So we weren't just improving animal welfare for the sake of animal welfare, we were also improving it with a view to improving productivity and improved genetic gain. So I'll just briefly touch on those 3 areas. So the first one is improved compliance with beef market specs, and so CRC science, beef CRC science, particularly CRC1 science, but also CRC2 science underpins Meat Standards Australia. And you probably all know that MSA is the world's only meat grading scheme based on or designed to guarantee palatability based on consumer preferences for quality. And you may or may not be aware of this, but MSA was released or started in 1999-2000, and we have done the economic analyses up to 2011, excluding 2012, and the value add to the Australian beef industry between 1999 and 2011 is more than $500 million. And now with the, MSA increased rapidly last year, or exponentially last year, and recently MSA, still led by Rod Polkinghorne, John Thompson, the original scientists. They tell us they've retired, but they're continuing to work in this area, and very recently released the MSA index that's going to better differentiate 3-star from 4-star and 5-star, or better differentiate 4-star and 5-star from 3-star, because the $500 million value add, excuse me, is based entirely on 3-star. No differentiation at all on 4 and 5-star, but there's huge opportunities to differentiate on the higher quality. We've also developed a range of tools over all 3 CRCs that will enable beef producers to improve compliance with market specs. Not only MSA, but MSA is clearly a key driver in this part of the world. And those tools are publicly available, and there are people in this room that are involved in developing them. There's the base model, which is just a calculator to adjust or to take measures of fat depth or weight, hip height, fat depth, and then predict based on knowledge of your pasture conditions or your feeding conditions how many animals will meet specs at some time in future. The drafting tool, I'll give you a quick example of that. The beef specs optimisation model is actually a feedlot based model. And so there are consultants that will work with the feedlot sector to help maximise profit in the feedlot sector. And the maternal model is just, it's in its prototype stage, or it was in its prototype stage when the CRC finished its research, but New South Wales DPI is continuing to work on that, and so that work is continuing. So these are the just the screen grabs. What I particularly wanted to show you here was, so this is just an entry screen, but here we have the drafting tool, and so what we can do is make predictions about how well animals are going to comply with specs. Clearly this square here is the grid, but you probably can't see the orange dots out here, but you can see the cloud. These animals will not meet specs based on the predictions, and there are individual animal IDs there, so you can make some decisions. You could change the way you are finishing those animals. You might defer slaughter on those animals. You might supplementary feed. It just gives you some options about how you could maximise your compliance with that grid. So that's a very useful tool. We've also been doing work in dark cutting. One of the ways that animals have slipped out of compliance is through ultimate pH temperature windows that are higher than, or the ultimate pH of greater than 5.7, and it ends up with dark cutting beef. So we've got management tools there, and these are pretty simple management tools, but it's, you know, time of trucking, the way you manage your animals, to reduce the failure due to pH problems or the dark cutting. And so there's a 2.8% decrease in dark cutting since 2006 as a result of applying these simple management technologies. The second area was improved cattle welfare. I'm just going to touch very briefly on this, but in our first term CRC we developed these two vaccines. One is specifically for bovine respiratory disease, which is this Bovilis vaccine. The second one is a vaccine that was developed by DPI New South Wales. This is developed by CSIRO et al. And this one does control BRD, but also controls reproductive losses. Those vaccines were clearly, they were developed in CRC1 and delivered in CRC2. They are now routinely applied throughout the feedlot sector in Australia, but measuring the impact of those technologies or these vaccines is very difficult. Obviously the way you would measure the impact would be through reduced mortalities, reduced morbidity of cattle in feedlots, or through improved reproductive rates of vaccinated cattle. But we had no way at all of being able to measure those improvements. So the only way we've been able to measure the success of this vaccine is through sales of the vaccine. And to June 2010, there were about $20 million of sales across the Australian industry of those vaccines. But they are now routinely used and they are successful. So in this current CRC, or in the third term CRC, we developed a diagnostic test for polledness. Now this is based on a DNA marker test. It was primarily developed for the tropically adapted breeds because there was no test at all available for the tropically adapted breeds. But since it was developed, it's been expanded and has been found to be shown to be useful to the temperate breeds of cattle as well. Now again, the impact of this technology could be measured by the costs of reduced dehorning, or the reduced losses due to dehorning. But the real impact is the market access. We don't want in the beef industry to see the same thing that happened to the sheep industry or to the wool industry due to mulesing. And dehorning, particularly in Northern Australia, has the potential to have a similar sort of impact. If the animal welfare lobby got hold of dehorning and decided that they were going to ban beef because of dehorning, it would have a major market impact. So that was why we were concentrating on polledness. The third area that I mentioned was improved genetic gains, and we've had three different approaches. The first was crossbreeding, the second was within breed selection, and the third is use of DNA markers. So I'm just going to touch very briefly on those three areas. And the first one is crossbreeding, and again this was done primarily, or was done entirely in CRC1, and was aimed at the tropically adapted breeds, because the Brahmins were shown, the Brahmins that predominated in Northern Australia were shown to have a problem with meat quality relative to other breeds. They are very, very well adapted, no intervention needed to control ticks or buffalo flies or, heat stress. They can cope with those stressors. But one of the consequences, or two of the consequences of such high adaptation is poor meat quality and poor reproductive performance. So we did some work looking at particularly the tropically adapted taurine breeds and the role that those breeds, and what I'm talking about here are the breeds that are derived from Southern Africa, south of the Zambezi River. There's a group called the Sanger breeds. There's a group of Criollo cattle in South America, Colombia, that area. They are tropically adapted. They are Bos Taurus breeds that have evolved in harsh environments, and we thought they had potential to improve Northern Australian beef production. And so that's what we were trying. I should also have mentioned the Senepol as one of those breeds. So the Senepol is derived from the Criollo. So what we were doing here was comparing Brahmins. So we had purebred Brahmins. This is in the breeding herd, terminal crossbred. So this is a composite breed or a tropically adapted breed crossed to a Brahmin to give a terminal crossbred, or a composite breed that was a three-way cross between the tropically adapted taurine breeds, the Brahmin, and the Bos Taurus, the straight Bos Taurus, the British or the European. And so in terms of gross margin per adult equivalent, primarily driven by growth or reproduction. So this is growth to weaning, $7 per adult equivalent for the terminal crossbred, and an additional $17 to the composite because of the improved reproduction rate. If we then finish those animals in a feedlot, the composites and the terminal crossbred ranked similarly, and there was an extra $38 for the composite or crossbred relative to the Brahmin for growth rate and feed efficiency differences in the feedlot. Conservative estimates of marbling, 10 cents a kilogram marbling premium on 15% of steers. The Australian Agricultural Company saw these figures and they said, we've done that cross because they've established these composites across Northern Australia. We've done that cross, and 100% of our animals go from 0 marbling score to 1 or 2. We had assumed that 15% would achieve that extra premium. And similarly, the CRC's own program showed that we assumed a 5 cents a kilo tenderness premium on 60% of fed steers. The CRC's own program showed that 100% of the crossbreds finished in a feedlot were able to comply with MSA 3-star. So that ended up with an extra $52 per adult equivalent. And if you then take that out to the northern beef industry and say that we've changed, or that the northern beef industry has changed 25% of its Brahmins to crossbreds or composites, which they have done, through to 2013, the impact was more than $1 billion. Now, we haven't been able to prove exactly what role the CRC had in that, or where the impacts come from. So we've been able to cost it out, but how we attribute it to the effort that the CRC put in versus the companies, and it's primarily the major pastoral companies that have made this change. But there is a big impact from that simple change. We've also looked at within breed selection. When the CRC started up until 1992, the only EBVs that were available, estimated breeding values that were available through breed plan, were growth traits. The CRC's data enabled introduction of scanned carcass traits, reproduction traits, the real life carcass traits, plus net feed efficiency. And in future, in the very near future, DNA markers will come in. And so the introduction of those new traits to breed plan based on the proportion of breed plan recorded bulls that are sold each year and are used across the industry, the value to Australia since 1992-93 of those changes is worth $700 million. So at a national level, there are big benefits. $1.84 per year for the use of scanned carcass traits doesn't sound much, but once you start multiplying it up to the size of the industry with realistic assessments of the usage, we're assuming that only 40% of bulls are sold with breed plan figures across the country. If we could achieve uptake of 100% of breed plan recorded traits, then the value is really in the billions. I'm just going to touch briefly on one test for, in this case it was a CRC2 test, DNA marker test for tenderness. This isn't the way we use the technology now, or will use it in the future, but I think it might help you understand what the technology's around. And so this was a DNA test for a marker called calprotectin that's associated with tenderness. And here we've got different animals. So what you need to do is look at the two top rows. This first animal has two markers in those rows, and that says that this animal has one marker for the unfavourable form of the calprotectin gene and one marker for the favourable form of the gene. This animal has two copies of the unfavourable form, and this animal has two copies of the favourable form. So when we talk about DNA markers, all we're talking about is this sort of differentiation. Whether an animal has, so what I should have said is that an animal inherits one form of a gene from its sire and one from its dam. And so we're just looking for the form of the gene that it's inherited and then its association with the trait. In this case, animals with the unfavourable genes versus the favourable, two copies of the favourable, there's about half a kilo difference in tenderness, or it's the difference between grading and ungraded MSA beef. So it's a big enough effect that it's worthwhile selecting for. But as I said, this isn't the way we're now using the technology. We're not going on a marker by marker or a test by test basis. What we're now doing is using what we're calling SNP chips, and these SNP chips are just exactly the same as the different forms of that marker, except that we're looking simultaneously at 7,000 of those markers at the same time, or 50,000 markers, or 700,000 markers, and increasingly we'll be looking at the whole genome sequence, but it's exactly the same technology. What form of the gene does the animal have? Has it inherited a favourable copy or an unfavourable copy from both the sire and the dam? And what we are able to do now is to use these lower cost, the lower density chips, these 7,000 marker chips, which are lower cost, and impute up to, use computer technology to just figure out, what the equivalent is in 50,000 markers and ultimately into 770,000 markers, and we're now working on the whole genome sequence. So hopefully this test will be $5 an animal, and you will get full information in the next 5 years that would give you, at the moment we can take this, it's not $5 a test, at the moment it's $40 a test, but the cost of the tests coming down, and we can very readily impute up to the 770,000. And so what you've got on a single test there is a prediction for how an animal will perform for any economically important trait. For feed efficiency, for carcass and meat quality, for reproduction, for methane emissions. So whatever complex traits you can have or you could dream up, then you would get that on a test. And so if you could use a 7K chip on all your weaners, if the cost comes down to $5 or less than $10 an animal, I predict that breeders will be taking a tail hair sample, or commercial producers will be taking a tail hair sample on all of their weaners and then getting predictions on how best to manage those animals, or which animals should go into the breeding herd. So, which animals should you target the B3 market for, which ones should you put into the breeding herd? And you'd be able to do that at a young age, less than weaning. And I'm anticipating we'll be there at that stage somewhere between the next 5 and 10 years. The technology is moving that quickly. And I've listed a whole pile of prediction accuracy. So these CRC delivered their tests into breed plan, and these are the accuracies of these different traits. Now, some of these accuracies are not particularly good. So retail beef yield, 13%. Eye muscle area, 16%. What that's reflecting is not a difficulty with the technology, it's reflecting that we don't have enough accurate measures of retail beef yield. So we only had the CRC 1 carcasses where we boned out, did full bone outs on all the carcasses. So what we need to do is find a different way of measuring retail beef yield to improve those accuracies. But feed conversion efficiency, this is going from no measurement, absolutely nothing known about the animals, to an accuracy of 44% prediction. So that's pretty useful if you're going from nothing to 44%. With the addition of measurements, with the addition of pedigree information, you can increase the accuracies now, and I would estimate over the next 5 years those accuracies should be up around 60% for most of those traits. But the limiting factor really is the measurement of those traits. So what I see as the future is smarter ways of measuring some of these very, very difficult to measure traits. And so I've already mentioned that we combined, I've just used tenderness again as the example. So we use these prediction equations, the genomic breeding values derived from those SNP chips, with whatever measurements we might have, shear force, taste panel, look at alternative measures. Flight time, measure of temperament, is correlated with tenderness and dark cutting. Meat colour is another one, and pedigree. So you combine all the information and deliver at the moment through breed plan. But as I've indicated, as the cost of the testing comes down, I believe we will have a very powerful, cost-effective tool for beef producers to manage their animals as well. Okay, so just to wrap up, some take-home messages. It's pretty ambitious of me trying to figure out what the take-home messages are from CRC after 21 years. But overall, we can prove that we've delivered more than $2 billion worth of value to the CRC, as a result of the CRC's technologies. But I do need to say that it's, CRC can't take all that credit. As I said, we can't figure out what value the CRC should claim from crossbreeding in Northern Australia, when the pastoral companies have been implementing. We can't take full credit for MSA. Clearly, MLA had a huge role in MSA. Our science has underpinned the scheme, but we didn't implement. So the commercialisers had a huge role. In the case of the vaccines, the commercialisers were also responsible for going out and marketing. So there's $2 billion worth of value add that we can, legitimately add up and say it was derived from technologies that the CRC developed, but we can't claim full credit. But we can say that the benefit of just 2 CRC technologies, without trying to attribute benefit to commercialisers versus CRC, the benefit of just MSA and just the new traits in breed plan has repaid the total $66 million investment by the Commonwealth in the CRC by more than 18-fold. So we have more than paid back what the Commonwealth's investment was in the CRC. Based on the genomic technology, the DNA marker technology, we are expecting the impacts of the CRC technologies over the next 15 to 20 years to at least be as great as the $2 billion that's already been delivered. The critical thing is that the outcomes could never ever have been achieved without collaboration. So there's, since the CRC has closed its research doors, the CRC partners are now trying to figure out how they can continue the collaboration, because it is as a result of the collaboration that we've been able to deliver the benefits. And we could not have achieved it without direct involvement of the beef industry. And so people in this room and people across Australia have had a role, not only the major pastoral companies invested more than $6 million, for instance, in the CRC's research, but many people have also collaborated through breeding animals to help us deliver these technologies. So we needed the beef industry and the partner organisations. So in terms of efficiency and profitability, the take-home message really is that beef producers should use whatever technologies will work in your own herds. I'm not saying just focus on CRC technologies. I'm saying be receptive to using whatever technologies you can find. Some of them might be as simple as yard weaning. We've been able to show big impacts of yard weaning. It's routinely used now across most of Australia. But that's a simple change in management technology. And has big impacts. Or it could be, using MSA or the DNA markers, but be receptive to the new technologies, wherever they come from. And the important thing to recognise, and I've not even touched on this at the moment or in the proceedings, is that one of the big drivers in future is going to be the methane emissions produced by beef cattle. Because of the need for carbon accounting and all the rest. We can't at the moment easily measure methane emissions from livestock, but we can measure productivity if we measure profitability. So any improvements, we have definitive proof that any improvements in productivity or profitability on farm will actually improve methane emissions, will reduce the methane emissions per kilogram of product. And so I would certainly be encouraging you to improve the efficiency and productivity, also to improve the environment. I'm just showing you here one way of measuring methane emissions. So clearly the animals, we're capturing the breath of the animals into these gas cylinders and then measuring the gas. So that's what would, one sort of measurement that might be needed if we were to measure methane emissions, but really if you just focus on productivity and efficiency, then you will also achieve reduced methane emissions. And I thought that I'd close this talk by congratulating a team of scientists, mostly from New South Wales DPI, that were heavily involved in the CRC and started our methane emissions work. Kat's one of them. She's going to talk here later today. These Australian Museum prizes are the equivalent of the Oscars in Australian science. And this team has been shortlisted for the Caring for Our Country Eureka Prize Award. I think it's the 4th of September. Kath, did you go down and to Sydney to see? There are 3 shortlisted finalists, and this is very prestigious, just getting to the finalist stage. So I thought it was appropriate that we acknowledge this team and the work that they've been doing. So thank you very much.